Question 6. The hydrogen ion concentration in water at 25 degrees Celsius is that. First question, calculate the pH. pH is given as the negative log of the hydrogen concentration. So just substitute negative log of 1.0 times 10 to the power negative 7. Negative log of 1.0 times 10 to the power negative 7. Okay, I'm getting a neutral. That's a 7.0. What is the concentration of the hydroxide ion at the same temperature? So it's basically the same. This is 7. Can you even guess? Okay, can guess. Anyway, the kW value at that temperature is about what? 1.0 times 10 to the power negative 14. So the kW value is the hydrogen concentration multiplied by the hydroxide concentration. So the kW value is 1.0 times 10 to the power negative 14 at 25 degrees Celsius. We've been given the concentration to be 1.0 times 10 to the power negative 7 for the hydrogen. So the hydroxide ion concentration, we just have to divide by that both sides, which we have. And you see that after dividing, you know that you maintain everything else. When you're dividing, subtract the powers. So it will be 1.0 times 10, and then negative 14 minus negative 7, it will be plus 7, which will basically just give us negative 7 as well. So it's of equal concentration about that temperature. The kW for water at 50 degrees is 5.476 times 10 to the power negative 14. Show that the elevated temperatures lowers the pH value of the water. So we are just have, let me just write something for you. At 25 degrees Celsius, the temperature is the kW value at that point is 1.0 times 10 to the power negative 14, and then for 50 degrees Celsius, the kW value there is 5.476 times 10 to the power negative 14. These are the two we're having. Let's try to assess them. We're increasing temperature in both cases. Now we have to show that when temperatures are increasing, it lowers the pH value. Now we know that kW is a product of the hydrogen concentration multiplied by the hydroxide ion concentration, and we know that at 25 degrees Celsius, where we've got our pH value to be 7 about that temperature, the concentration of these two are equal, which is 1.0 times 10 to the power negative 7 molar concentration. Yeah. So how do we show that indeed the temperature does decrease? So let's take an assumption that even at this temperature, the concentration of the two are also going to be equal, or let's assume the water was neutral. So if we assume the water was neutral, we can try to calculate the new concentrations of these. Take note of kW value was 5.476 times 10 to the power negative 14. So if we are saying they are of equal concentration, we can take them to the value of x times x, which will be x squared, and then try to find the square root of that value. 5.476 times 10 to the power negative 14, square root of it, something like 2.34. So the new concentration value here would be 2.34 times 10 to the power negative 7. So which entails that we've seen an increase in the concentration of the hydrogen ion concentration. Okay. Now, if you're seeing an increase in the hydrogen ion concentration, the pH is dependent on the negative log of it. Okay. One thing that you need to know is the higher the concentration, the lower the pH. So since the hydrogen ion concentration has increased, with an assumption that the amount of hydrogen, or the amount of the protons and the hydroxides were equal, the pH would be what? So the pH in this case would be lowered due to an increase in the hydrogen concentration. So we've shown that indeed when you increase the temperatures, the pH value is lowered due to an increase in the hydrogen ion concentration. An increase in the Kw value, if you look at it from an equation point of view, there is basically directly proportional to what? It's directly proportional to the hydrogen ion concentration. Now the hydrogen ion concentration is inversely proportional to the pH value, and that's why. Now B, the Kw, what is part 2 now? What is the concentration of the hydroxide in the water at this temperature? I think we've already calculated that. I ended up already calculating. I said Kw is equal to the hydrogen ion concentration, hydroxide ion concentration, and then we took an assumption that the amount of the two were equal, so we had to put in the value of X and then plug in the value of Kw given there. So we got something like 2.34 times 10 to the power -7. And then comment of the water concentration in relation to 25 degrees Celsius. I think I already made a comment about that temperature, 25 degrees Celsius. The water was neutral. That's why the pH was what? The pH was 7. A solution with an hydroxide concentration of that, what is the pOH, what is the pH? Simple and straightforward. Whenever you are given the value of the OH, you can find the pOH. So the pOH is basically equal to the negative log of the hydroxide ion concentration given, which is 1.20 times 10 to the power -7, negative log of 1.20 times 10 to the power -7. So that gives us a pH of 6.92. What's the pH value? pH is given as 14 minus the pOH, since the addition gives us 14. So subtract the 6.92 to see what we're going to get. So grab your calculator, subtract 14 minus that. So approximately value is 7.08. That's the pH. So we have both the pH and the pOH for this question. So we are done with question 6. So this is where we end for this free lesson. To access the solutions to the other questions that I already showed you, kindly sign up using the link in the description. So these are the questions that are answered in the full video, all the way from 7. These are more complicated questions, as you can see. So you can actually watch the solution full by either subscribing on YouTube Premium or visiting our website for the local subscribers. Enjoy your day. Thank you very much for taking time to watch a video.